Hello, my name is Mateusz Buda. I am a senior gameplay programmer at Flying Wild Hog. I would like to talk about benefits and pitfalls of using gameplay abilities system based of our experiences when developing our games. First of all, I would like to do a quick reminder about what are the parts of gameplay abilities system, so we are all on the same page. First of all, we have gameplay abilities themselves. Then we have gameplay attributes, which are numerical values. We have gameplay tags, which can be thought as a sort of flags. We have gameplay effects that are responsible for changing tags and attributes. We have gameplay cues that are visual representations of the effects. And we have gameplay events to communicate between those. I would like to start talking about the benefits. As a studio, we are sure that we are not getting 100% out of gameplay abilities systems yet, but still there are parts of it that we found to be very helpful and that sped up our development process greatly. The first thing is that gameplay abilities allow us to easily define rules and conditions for character actions to actually perform. This was one of the most basic problems on each of the projects I've been working on, and it always took some time to implement complex logic that it requires. With gameplay abilities, we can define those conditions using tags. And what is great is that we only need to think about what matters in the context of a given ability. So, for example, our attack ability only needs to know that it has to cancel protection abilities and that it should block any reactions or traversal abilities. When we combine those conditions from multiple abilities, we get quite a powerful state machine that is still easy to set up and easy to modify. What is more, those tags can be added by a notified state in animations, which make it it's easy to create an ability that can be triggered only in a specific time, like, for example, a parry ability. What was a huge win for us was in the area of AI development. Thanks to gameplay abilities, we actually needed only one behavior tree task to execute all the actions our AIs do. And our behavior trees use only this one task and move to task. What is more, we could move some of the conditions for the actions to inside the abilities. That way, when designing behavior trees, we can focus more on what our character wants to do, and we do not have to think about the specific detailed conditions if it can do it. If it can't, the task will simply fail. And another thing is that we can reuse portions of the behavior tree. Because, of course, different characters have different abilities that look a little bit different, but they can still have the same tags. So the behavior tree I am showing here can be working on all of our enemies' AIs without any change. Another thing related to AI development is that we could do a good reaction system without any additional logic in the behavior trees or in the gameplay code. We could just focus on reactions that only do that, they react. We have this set up as a list of abilities that are triggered by gameplay events. They are usually sent from damage callbacks, and the abilities themselves handle the conditions for triggering and canceling other abilities these conditions are being set up by tags, as I mentioned earlier. Another good thing for us was easy debugging. To be honest, we had a lot of issues concerning the gameplay abilities. There were a lot of bugs, but mostly they were from abilities conflicting with each other. Either one has not ended or two abilities triggered at once. And these bugs were very easy to fix, and they were easy to find. For finding, we use two built-in tools, and it is Gameplay Debugger and Debug of Ability System. Both show active abilities, active gameplay effects, owned tags, and additionally, the one on the right also shows active ability tasks within the current ability. Other advantages of the gameplay ability system are that the logic for our actions can be very simple. Actually, by now, most of our abilities are basically play an animation montage and then either apply a gameplay effect or apply damage. We can use gameplay effects to do easy buffs and debuffs like multiply damage or increase resistance or something like that. What is very important for me personally is that the gameplay ability system has events for almost every change of its state, and that makes it very powerful. Thanks to that, we can have easy callbacks on attribute change. So, for example, there is only one place we need to handle the health attribute going down to 0, and we do not need to think about where it could be changed. Also, these callbacks allow for easy communication with UI, where the UI can just listen for the events sent by gameplay effects or the gameplay events in themselves, and show appropriate things on the HUD. And it can be even easier while using gameplay cues. We also had some problems with abilities. Some of them was because of our misunderstanding of the system, but still they made our work a little more challenging in some places than we would expect to. First thing I would like to say about is that gameplay abilities system exposes very little to blueprints. It is not a bad thing. I would even argue it's a good thing. But when we started development, we focused on very rapid prototyping, and we did most of our work in blueprints. And because of that, we simply missed a lot of features that were in the gameplay ability system, but we did not know about them. What I mean are mostly callbacks for the ability, gameplay effects and events, details about gameplay effects and details about attribute changing. We found them only later when we started to debug the code, and we found out that many things that we struggled with could be done with a few lines of code that we didn't know it existed. One of the biggest problems we had with abilities is binding input to it. By default, you can bind one input per gameplay ability, and those inputs are defined in the code by a special enumeration. That means that when your designers decide to change the list of input actions in your project settings, you will need to change the code to reflect that, and it is not very easy. Also, assigning the input is not intuitive either because you essentially put in the integer value from that enumerator, and that is not a thing that is easy for a designer. So we started to think about some workarounds. Our first approach was to use abilities that are triggered only by gameplay events. We have generated tags for each input actions. We created press, release, tap, and hold events, and we're sending those events each time the input action happened. This allowed us for some greater flexibility. Most of all, it allowed us to play different abilities based on the input, if it was tapped or if it was held. But setting up the input within the abilities themselves and scrolling through that quite a long list was a little bit inconvenient. For our second approach, we decided to move the input handling externally to the controller class as we would do normally. And we trigger specific abilities explicitly using tags. This allows us for complex inputs such as abilities that require two buttons to be pressed at once, or ability triggered by a double tap of a single button. And also this allowed for a little delay of the ability activation when needed, which led us to a simple queuing, which I will talk about later. Another thing we misunderstood are the gameplay queues. At first, it looked great because we had this one list that we could go through and set up all of our ethics. This was great for our artists because they did not need to look into different places and folders for blueprints to attach their assets. They could just do it in one place. And as for us gameplay programmers, it was great that we found out that gameplay queues have pooling mechanism already implemented. Also, we have found translators which allowed us to do variations of a single effect. The example here would be a hit impact that we could trigger with a single tag, and it would show different particles depending if we hit wood or rock or metal. All of that was very promising. It was such good promising that we decided that it will be our main way to deal with all the ethics. But this proved to be a double-edged sword, and we had some problems with it. First of all, there are two types of gameplay queues. One is static and one is actor. The first one is sort of fire and forget. The other one is more persistent. It turns out that if you create gameplay queue that is static and later it appears that you will need an actor after all, then it is hard to change between those two. You basically need to create a new gameplay queue and do everything from the start. Also, gameplay queues require ability system to work. So what I said before about hit impacts, it would only work on character actors, but it would not work on hitting actual rock or tree in the environment, and because they don't have the ability system. And we worked around that by executing such queues on the player character, which we consider not a very efficient way, and it poses some problems also to us. Another problem with gameplay queues is that they have very few parameters available. So we need to use some workaround for passing hit results, which we need to use a lot. And for example, if we want to pass two factors, for example, start and end of trail visual effects, we need to pass one disguised as a normal factor. If we did need to send three factors, then we did not found any way to extend these parameters set. Also, what I said about translators, they quickly exploded with combinations for us, and that resulted in a big list that was hard to maintain, and it was difficult to find an actual gameplay queue to either set up or modify. And when we were closing on our milestones, it became clear that even with all of these queues, we were unable to customize our visual feedback in the way we wanted to. Because we approached this with the wrong ideas in our heads, and only now we are figuring out how to improve on that. Other more minor things that were challenging for us is that only one animation montage is supported from gameplay abilities system, and it doesn't matter if the slots are different or not. It's just that inside the gameplay ability system, there is only one field for storing montage data. Also, when we were working on our ammunition attributes and handling its values, we tried to modify attribute values directly, and found out that in some cases they do not update the way we expected to. But this was a very specific case, so it might be that we approached it in the wrong way. And the last thing is that setting all the data for the ability system of characters can be a little tiring and inconvenient. Actually, it does not need to be, because it is easy to expose few variables to set in the code to set up initial attributes and abilities, but we always put it for later and later, and as a result, we now stuck with a solution where while spawning a character, we always need to apply two gameplay effects on it. One to set up initial attributes and one to give initial abilities. And it is a little inconvenient to set up by designers. I would like to show you some examples that we encountered during our development. First of all, we have damage handling. When you use gameplay abilities system, it is natural you will want to have your hit points as an attribute, and it should be changed by a gameplay effect. But a gameplay effect only makes sense on actors that have the ability system. So, for example, on characters. It will not work on, for example, a destructible object in the environment. So you will need some other way to handle that. Also, the gameplay effects are kind of sideways of the normal damage flow of the Unreal. And in fact, one of the first questions we got when we started to implement it was why the God mode is not working. Well, it was not working because it was a different system, basically. So now we use basically a default Unreal's damage flow. We use apply damage methods normally as we would in other projects, and only with characters we override the take damage method, so so that we apply a gameplay effect there, which modifies our health, and send a gameplay event that triggers reaction abilities. It works very well. The only problem we had is that when we get to the callback that is called on health changed, we do not know the reason for the change of this attribute because damage type got lost in between. So we handle that by discussing damage type object as a source object for this damage effect. Other problem we had was with responsive attacks, and it was very, very important for us because our games have a very fast-paced gameplay. We did not want our attacks to interrupt each other, so we had our attack abilities block all other attack abilities. But when they do, the player inputs were ignored until the attack ability ends. That led to the feeling of unresponsiveness. We tried to fix that by ending ability earlier and keeping the animation, but the inputs were still being ignored. So we then moved to add additional logic to attack ability that would listen for the inputs assigned to attack action and try to either retrigger current ability or trigger another one. And this logic quickly became very complicated. We had a lot of bugs with it, and it became increasingly difficult the more attack abilities we were adding. So in the end, we decided to move the attack input handling externally to the controller, as I said before. And there we could trigger the attack ability explicitly. We could then check if it succeeded or if it failed. If it failed, we could remember that we tried to activate it, and we could try once again when the current ability would end. And that approach led us to extending the ability system component with a simple ability queue, which, to be honest, works better than I expected it to do. Another case with the automatic reloading. Actually, this one is pretty simple. We wanted our weapons to reload always when there is no ammo in the magazine. And it is quite easy. The reload ability is very simple, but we had a problem when should we trigger it. We started by adding manual checks for the value of ammo attribute and manual reload triggering of reload ability, but it was easy to make a mistake there, and also we had some bugs with that approach. So then we tried to trigger the reload within the execution of attack cost effect. So in the exact place where the ammo attribute is being changed. And we had two problems with that it either happened immediately and it was breaking the attack animation, which looked bad, or it blocked. If we blocked that, then nothing would happen because attack would block the reload ability. So in the end, when we rediscovered attribute callbacks from code, we made an external component that was listening to the ammo attribute value change. When it detected that it go down to 0, then it started listening to the end of the current ability, and then it would try to execute the reload ability. And the last example is adding a visual feedback for the slide ability. We had this is the ability that we use in our combat, and we wanted some detailed visual feedback on it that includes camera shakes, modifiers, and sounds. And it was not a problem. We did it in the activate ability, cleaned it up on end ability, and it was working fine. But we came to an unexpected problem when we had to add another slight movement on the level that is forced by environment and level designers. And it is not the same as this combat-related ability, but it should have the same feedback. So we started with just copying the code, but thought there should be a better way. And actually there is. We then introduced a gameplay effect for the slide with a dedicated gameplay queue for it. And within this gameplay queue, we had on active, while active, and removed events that we could use to implement all this visual feedback. And then all we had to do was to just apply this gameplay effect in the right moments. So to sum up, thanks to gameplay ability system, we were able to do a very fast development. In fact, we made most of our basic gameplay mechanics in less than 3 months. After that, we were able to easily extend the behaviors and reactions of our AIs, and we were able to easily show the visual feedback of our actions, be it on the enemy characters or on the player's HUD. This all led to less bugs for us, easier refactorings, and also a simple functional test. We made also some mistakes, and I would say the main one was that we started to invent workarounds before we fully understood the system. Also, we were very, very reluctant to move into the C++ code, and we over-relied on blueprints. That led to those blueprints being very complex, spaghetti-like, and the actions were much more complex than we expected them to be. We also misunderstood the use of gameplay cues. We did not use them enough in the places we should. So, for example, with the effects that should be shown or HUD. But instead, we added too many cues that we should probably handle in other ways, such as footsteps or hit impacts. I would like to say, to end with some advice. First of all, it would be to look at the ability system component header file and see what is available there, because there is a lot of great functionality there that is easy to miss. So it's good to know what is there. Also, if you're working mostly on blueprints, at least consider exposing some of the ability system callbacks, like the ability events. Or you could just focus on C++ coding from the early stage of the project. You should make your own ability tasks often. Do not be afraid of them, because they can make the logic more clear and easy. Do not forget about gameplay events and gameplay effects also. And lastly, try to keep the abilities logic as simple as possible. If it becomes too complex, it is a sign that it should be moved to another place, either to an ability task or to an external system. And that is all from me. I will now be happy to answer all your questions. Thank you.